Hi, welcome back. Today we will continue working on our latest project, Bring Me a Screwdriver, and we will implement YOLO, an object detection library to detect this screwdriver, okay, using the camera mounted on the robot grabber, as you can see. At the beginning, I want to introduce a special thanks for Robot Mania on his great work. If you follow this link, you can find his original video. He proposed several corrections for the label ROS2. So in order not to do everything from the beginning, I forked this repository and made the necessary correction and kept it in the repository in order not to do everything from the beginning, as I said. Next, you should follow the steps. So you will copy those commands and paste it here in your terminal and press enter. I already cloned it, so no need to clone it again. Then copy those commands and paste it here, enter. I already installed those packages before. Okay, now we are going to copy this line. Okay. I already opened an SSH connection to the Raspberry Pi. This application for controlling the robot, and this one for capturing the G streamer, capturing the image from the remote camera mounted on the robot grabber. The password. Okay. Let's continue. Python 3 capture gstreamer.py. Copy, paste. Okay, now you can see the image from the camera, but it's pointing toward the ceiling, as you can see here. All we have to do is controlling the robot to orient the camera toward the screwdriver. Okay, now I am going to press X, C for the third joint, okay, then B, the fifth joint, okay, now it shows up. Let's control the fifth joint. Now the third joint, a little bit more. Let's center the screwdriver. We need to control the first joint. exactly. Yes, as you can see here. Move it to the center. I am pressing A. Okay, that's fine. To save, you need to click on the image and press S. As you can see, let's connect the Docker container. Reload window. We are connected to the Docker container. Wait a little. Okay. YOLO V8 OBB data for training. Now, this is the captured image. Okay. I will rotate the screwdriver and come back. One moment. I rotated the screwdriver and I will take more image by pressing S. Now we have 2 images. Okay. We will repeat this for different positions, and once we finish, we should move the robot a little bit more toward the screwdriver. Okay, from here I'm going to control the base from the keyboard. Now you will see the whole robot moving. I'm just pressing button number 8. Watch this. Okay, I moved. Okay, as you can see here. And then we need to adjust the position of the screwdriver. So I'm going to press A. Good. Then I need to control this joint, number 3. Okay. And also joint number 5. Okay, until the screwdriver is in the center. This is a good one. Okay, I will come here and press S. A new image has been generated. 0, 1, 2. We need to take several images at different distances. Okay. By repeating the steps that we just mentioned in the instructions right here. Okay, now let's move forward. Go back and then navigate to the label image 2. In the data directory, predefined classes.txt, add screwdriver at the beginning. Let's see. Data directory, predefined classes. Inside the label image, data, predefined classes. Let's add the screwdriver. The canvas. Let's move forward. Python 3 label image.py. Copy, paste, open the directory for the new image. ROS mobile Moveo source, data for training, shoes. Okay, all the images right here. We are going to press here and draw a rectangle like this, and then with the right mouse button we will orient the rectangle, okay, and center the rectangle around, exactly around the screwdriver, like this. Okay, then save and move to the next one. Do the same and make sure this line, the dotted line, always oriented in the same direction. Okay, aligned with the screwdriver. It's beginning from the base and moving in this direction. Okay. Okay, let's center it a little bit more. Okay, Control S to save and do the same thing for this image. Okay, use the right button, mouse button, to rotate the rectangle and this, and then put it in the center. Little bit like this. Control S. Okay. Now we annotated all the images. Okay, let's close this one and check this directory. Version 8 OBB data for training. What happened? It added a new file for every image, an XML file for every image, and it contains the rectangle that we made for the annotation. Okay, as you can see here. This is the coordinate for the rectangle. Let's close this one and move forward. We already made the annotation. CD, go back, and CD YOLO version 5 utils, copy, CD, paste. Let's execute this one. Make sure that everything is okay. YOLO version 5 utils, data for training class. Okay, let's copy this line and paste it here. No such file or directory. Let's make sure home. Can't open file. YOLO version 5 obb.py. Oh yeah, because we don't need this anymore, because I'm in the same directory. Oh yeah, let's go back and fix this one. Okay, now let's copy this line, paste. Let's check the generated files. Okay, at the beginning we had the image 0, 1 and 2, and we made the annotation, so we get the XML file. And after running this, the last command, we now have the rectangle coordinates, but in different format. Okay, a text file, a new text file for every image. Image 0.txt, image 1.txt, image 1.text, and image 2.txt. Okay, let's continue. Go ahead and navigate to the training folder. Paste. Let's CD source. Okay. Now we need to prepare the datasets, screwdriver and dataset image label. Let's check the training folder. This is the training folder and datasets. Robot Mania was preparing a dataset for bolts. I prepared a new dataset for the screwdriver, as you can see here. So I put it in the same directory. Through screwdriver dataset, the image, it contains train and val folders. In the train, simply add all your images here. Okay, as you can see, I selected about 10 photos, 10 images for evaluation. As you can see here, image 48, image 49 is missing. No, it's not missing. It's actually located in the evaluation folder right here. This is the image 49. So at first, put all the image and select randomly 10 photos and put it in the evaluation folder. And do the same thing. Do the same thing in the labels directory. It has 4 folder: train original, evaluation, and the evaluation original. Okay. Put the text and the XML files for your training image in the training original. Okay. And put the text and XML files for evaluation in the evaluation original. This is for the 10 photos for evaluation. Now let's check what we will do next. Python 3 format converter.py. Okay. Let's check the format converter.py. It's located here. Okay. Let's search for the screwdriver. Okay. Should add the screwdriver here and here also. So now we are ready for the evaluation, for the training, I'm sorry. Let's check again. Python 3 format converter. After executing the format converter, at the beginning, train and val evaluation folder is empty, but after running the converter, you will find the new files here. Okay, let's check again. Paste Python 3 format converter.py. Okay. Now the new files is here. As you can see, the coordinates have been changed, have been modified, and actually normalized. So the coordinates new range would be from 0 to 1. Let's move next. Adjust the train info.yaml. Train info.yaml. Okay, screwdriver dataset. Now we have the screwdriver dataset here. Our dataset, screwdriver dataset. Image train, image evaluation, and the class. We adjusted the YAML file. Now let's perform the training. Okay, run this file. It should take some time to perform the training. In the training, as we see, we have 100 ebook. Okay, as you can see, the train is being done. The training is in progress. 81, 82, 83. Okay. Result save to runs OBB train 6. Okay, let's check. Runs OBB train 6. Waits. Okay, this is our new wait file. We will take this one, copy, and go to the YOLO version 8 OBB scripts and paste it here. Okay, now let's move to the next step. Copy the best.py file. Okay, for testing, run this file, Python 3 YOLO v8 OBB webcam. Let's check it. Copy. Let's check again. Oh, it's already here. Paste. As you can see, the screwdriver is being detected. That's great news. Okay. Okay, now let's proceed. We will build the workspace. Okay, it's completed successfully. I already opened 2 more terminals at the same Docker container. ROS2 run OpenCV publisher node. This one is for capturing the network GStreamed image and publish. It receives some the image from the Raspberry Pi through network and publish it on the uncompressed image topic. Okay. Okay, let's move next. Copy. This one is for making the object detection. And finally, we need to run RViz. Let's add an image panel and adjust the topic, inference result. Okay, that's perfect. Okay, let's put this one here. Image. Okay, let's put it here. And Let's move this one right here. Let's move the robot forward a little bit more and check our performance. Okay, let's move it to the left. Let's move it back a little bit. Okay, let's move it a little bit forward. Let's center it a little bit more. Okay. Let's removing the manipulator a little bit. Okay, let's check. Okay, as you can see, we have a reliable performance. Let's move back a little bit. Okay, let's move forward. Okay, thank you so much.